Hello, welcome to the workshop. I thought today I'd show you a video about pressure. So, what's pressure? I'm talking about air pressure today. And if you remember, I made a pressure jar. Those of you might have watched the video for making the valve for that. It was quite long, it was about 50 minutes. Pressure is quite simple. Let's think about a couple of atoms. That's my fist, just in case you're wondering, those are atoms. And they bounce off each other. You know, they're just banging about and they're banging off each other all the time. And that's what creates the pressure. Because they're trying to bounce away. Now if you separate them, it's, you know, there's less pressure because they're not, if you push them together, they're like, lots of pressure, lots of pressure, lots of pressure. And that's what happens. So if you compress them together, they start like this, and as you compress them together, the pressure goes up because they're going. So pressure and volume are linked. Now it's an interesting thing this, because temperature is caused by exactly the same effect. So atoms bouncing off each other, that movement is heat, is energy. So as they bang off each other, that's what temperature is. And if they hit a surface, they'll transfer some of that energy to the surface and heat it up. So that means that temperature, volume and pressure are all linked together through gas laws. If you're really interested in the physics of this, it's called Boyle's law. Go and look it up. I'm just going to show you. So how can I show you that? How can I show you this link between volume and pressure? Well, I built a pressure jar. What we need is a known volume that we can compress. Oh, we need a balloon. A balloon's of known volume. My lungs are of known volume, it seems low known volume. I need to have my seat more off and run about. There's a known volume, don't know what it is, don't care. It's covered in mush. So that's my known volume, and I'm going to put it under pressure. It's going to contain the same air, the air can't get in or out, so that's a known volume. And all I've got to do is somehow put it in this jar. I'll zoom you in for the laugh as me trying to put a balloon in a jar. I don't know why I set myself up for this stuff. This is one of these 20 minutes later videos. And Bob's her uncle. That was a hard bit, the science is the easy bit. Right, so I've got a known volume in there. I'm just going to screw a lid on. And pop it in my apparatus that we made. And we'll screw that down nicely so that the pressure stays in the jar. I've got to tighten these up in a nice order or it'll work. Okay. There we are. So I think you can see that okay. Now if I connect a pipe, the compressor pipe to the top of that, I'm going to put a safety mask on just in case. I'm mad, I'm not stupid. I'm not going to lose my eyesight just for a silly experiment. You know, if there's a chance I could solve world peace or feed the poor, then I'd go for it, but that's not what we're doing here. Right, and pressurise that. And you can see that my known volume is now reducing because the jar is under pressure. And right now we've just reached 2 atmospheric pressures. And I don't know if it's half the pressure or not, but it's certainly less. It's half the volume. Okay, we're just coming up to 2 bar, which is quite a lot of pressure. That's why I'm wearing a face mask, because if that jar goes, it really, really won't be funny. Okay, that's 3 bar. I'm just switching off the little needle valve in the top just now. Okay, and I'm going to take the pipe off the top. You hear a lot of noise. Don't worry about that, that's just the compressor depressurising. So, look how small it is. Because there's more pressure in there, it's crushed it. It's crushed the air quite substantially. The same amount of air is still in there, believe it or not, and I can prove that. Yep. The same amount of air is still in there, of course, and I can prove that by simply releasing the pressure and bringing it back to the pressure it had before, and the air in there should expand again. And there you go. Let's come back up to pressure, and we're back to square one. Take my mask off, and all that happened was we crushed the air down. Now what about this temperature thing? Well, we could simply put a thermometer in there and see what happens to the temperature. So let's get that out. One thermometer. One squint lid, not a good idea. Okay, thermometer, airline. So we're at about 25 degrees there or something. Yeah, you've got a better view than me. So we're going to start pressurising that. Okay, so that's up over 3 bar, and you can see that's risen to about 27 degrees centigrade. So what's happening there is that the air is being crushed, pushing the molecules together and causing it to be warmer. So that's about it, about 27 degrees. If I release the pressure now, you'll see it start to drop back. There we go, it's down almost to 25 already. Now, if I was a bit more sophisticated, I could show you much more sensitive changes in temperature and stuff. I've just used a pound shop thermometer there. But you get the idea. So that's it. That's how pressure works. That's the relationship between pressure, volume and temperature. The more you crush things together, the higher the pressure, the lower the volume, and the higher the temperature. If you release, the higher the volume, the lower the pressure, and the lower the temperature. Brilliant. See you next time.